Welcome to my presentation on parallel random access machines. My name is Ali Jaffer. This is a recording done for our final project in cs301 at UIC spring 2015. We were told to decide on a topic, and the one that I thought was most interesting was parallel random access machines. Throughout the semester, as many of you know, we've been learning about regular expressions, push-down automata, and finally Turing machines. When we got to select our own topic, I thought it was interesting to look at parallelism, particularly because most of our computers are dual-core, quad-core. There's even some 8-core machines that are out there. And then if you start looking at servers, many more distributed systems. So I wanted to investigate a little bit more and see if there was a parallel Turing machine. When I started to investigate that, this is what popped up. This is actually in section 10.5 of our book, but they didn't want to go into it, so I had to do some other research and find out more information online. So let's get started. Parallel random access machines. Parallel random access machines is a system that comprises of many random access machines that are going to run in parallel. So those are the regular Turing machines, M1, M2 to MI. There's infinitely many of those, as well as infinitely many input cells, X1, X2, X3, Xi. Infinitely many output cells, Y1, Y2, and all the way to Yi. And finally, there's an area of shared memory cells, A1 to A2 to AI. So how does this all come together? There's 5 phases of computation. For each of the processors, at one clock cycle, they get to read from an input cell. They also get to read from any kind of shared memory cell. They get to perform some internal computation, and then they have the ability, if they choose to, write to an output cell or write to a shared memory cell. Because of this, conflicts can occur. If you guys have taken OS at UIC or mobile app development this semester has talked a little bit about it, when you start using parallelism, conflicts occur because you have two people trying to update the same data. Processors are, in this case, writing to the same cell. Because of this, there's been 3 ways to handle such conflicts. There is crew, basically, where only one person can write at a time, but everyone can read concurrently. There's common, which basically allows anyone to write if they're writing the same value. And then priority. The lowest I of the MI machines will get its written value put into the cell. So there's a lot of different examples of when parallel programming is used. I thought the example that was easiest to understand was min or max of a set. So first of all, let's think about how you would do this if you only had one processor. You would have to go through the list, the set, look at each element, identify if you had seen a min or max of it before, if you had updated to that value. If not, you continue on. So this is a linear time algorithm. To do this with parallelism, we're going to have actually n processors for 2 to the n inputs. And then basically construct a tournament style where values are compared at each step. We're going to compare 2 outputs, so each processor will compare 2 outputs, take the max and put it into a shared memory area. Then another processor will then look at that 2 shared memory areas and find the max and go from there. So looking at what that means is basically processor 0 is going to find its max and push it forward. Processor 1 will do the same thing, processor 3, and so on. So then you get the max of the 8 values to now that there's 4 values that possibly could be the max. Now you only need 4 processors. They can all check the max and move it up to the next level. Then you only need 2 processors, and finally the 1 processor that decides between the 2 final inputs. This algorithm can actually be done in log of n time. So in conclusion, parallel programming is definitely the way that we're going into the future. With more and more cores, I think this is an important topic for us to research. We didn't get to touch on it much in this class, but I think it's really relevant for all of us, and I thought this was a great learning experience for me. These are some references that I used. Please contact me if you have any further questions. Thank you for your time.